Hello. So the first video of this course is devoted to the basics of econometric analysis and general philosophy of this type of research. I mean, principles and methods. I'd like to start with the borderline between qualitative and quantitative research. Trust me, it's important. You're going to understand this. So it will start with analytical process featured by qualitative and quantitative research. In the first case, it's all about analytical induction, and in the second case, it's about deduction. I will explain. So in very simple terms, inductive research is when you have no knowledge about certain phenomenon, but you'd like to investigate this phenomenon. So typically, qualitative research is used in anthropology, ethnography, and psychology. And I have a good example for you from anthropology. So many decades ago, anthropologist Theodore Daves had to investigate heavy drinking behavior among indigenous people in one of the American towns. He had no prior theory to base his research on. So for instance, if you know that heavy drinking is caused by child trauma or low level of education and so on and so forth, then you can concentrate on these variables only. However, if there is no such prior knowledge, no prior theory, you first have to collect data and try to determine the most important factors, like what actually causes people to drink that much. So he collected some interviews, made some survey, conducted several field studies, and he explained heavy drinking behavior from the perspective of time orientation, which is one of the cultural dimensions, but this is not what we discussed today. So what I wanted to conclude based on this example is that in qualitative research there are no prior hypotheses. You do not know on what variables you'd like to concentrate, what variables are the most important, and your task is to determine those potentially important variables. In contrast, in quantitative research, which is hypothetico-deductive, there is already some prior theory to base your research on, and this theory allows you to state research hypotheses. So for instance, the neoclassical model of economic growth expresses the relationship between per capita income and per capita state of capital in a form of mathematical equation. So based on this, I can already say that theory predicts that higher stock of capital causes higher level of income. I already have a research hypothesis. So in my research, I do not have to explore hundreds and thousands of potentially important variables. I mean, potential determinants of economic growth. I can just concentrate on the variables specified by theory. So that's why we call it hypothetico-deductive type of research. When it comes to research design, qualitative research is observational, holistic, and flexible. So this means that you do not know what factors are potentially important. That's why you have to concentrate on the entire complex of these factors. So that's why it's called holistic. In case of quantitative research, it's reductionist and closed. So reductionism is a very complex term, but in this context, it can be explained in the following manner. So you already know what variables are the most important. That's why you are able to cut off the rest of those variables, which are either insignificant or much less significant in comparison to the variable of your interest. And finally, when it comes to qualitative research, usually it requires some human interpretation. In quantitative research, you have to analyze the relationship between variables. Usually you use numeric data. Even if there are some quantitative data, they can be transformed to numeric data. We're going to discuss it later. And in quantitative research, regression analysis is one of the basic techniques. So regression analysis is used in order to test some predefined hypothesis based on existing theory using numeric data. So this is what we're going to do during this course. Please keep in mind that quantitative research and econometric analysis in particular always require some prior research hypothesis. It's impossible just to pick some variables, and test maybe there is some causal relationship between them. No, this is not how it works. So when it comes to the process of econometric research, as I said before, you start with statement of theory and research hypothesis or hypothesis. You specify the mathematical model. In economics, it's relatively easy because most of economic theory is expressed in terms of mathematical equations, so you will not have any problems about this. Then you specify statistical or econometric model. You collect the data, concentrating on the variables you'd like to include to your model. You estimate the parameters. You test hypotheses. If needed, you make forecasting and prediction. And finally, this is not that relevant for this course, but in general, this is the purpose of econometric analysis. You have to formulate some reasonable policy advice. So based on obtained result, you are expected to propose some policy. Okay, so here you can see some examples of research hypotheses. For instance, when inflation increases, unemployment rate decreases. This is something based on economic theory. There is a mathematical equation explaining the relationship between those variables. That's why, it's an appropriate topic for econometric research. When government spending increases, increase in GDP exceeds initial increase in autonomous spending. So this is something arising from Keynesian cross model. Again, there is some prior theory I base my hypothesis on, and that's why I am able to formulate this. Households spend fixed proportion of the marginal unit of income. Again, this is something arising from Keynesian cross model. The increase in capital stock is associated with increase in per capita income, something arising from the neoclassical model of economic growth. So as you can see, when it comes to research hypotheses, they should be based on some solid theory. It's not appropriate just to pick several variables and try to analyze the causal relationship between those variables. Okay, so in very simple terms, regression analysis is concerned with establishing causal relationships between different variables. You try to estimate or predict the mean or average value of the dependent variable depending on the values of independent variables. So you want to understand how GDP growth rate depends on the stock of capital and the level of human capital. You want to understand how the rate of economic growth, again, depends on the rate of inflation and the volume of investment, something like this. So it's very important to understand the difference between statistical and deterministic relationship. So statistical relationship deals with stochastic or randomly distributed variables. So you know for sure that crop yield depends on rainfall, temperature, amount of fertilizers, type of soil, climate, number of sunny days, and so on and so forth. However, this phenomenon is too complex to predict. There are too many variables and relationships between them are too complex in order to express them in the form of mathematical equation. In contrast, when it comes to deterministic relationship, it can be always defined in the form of rigorous law. In physics, it can be Newton's law of gravity. In economics, it can be about gravity model of international trade or international investment, and so on. So this range of independent variables, I mean potentially important factors, is small enough in order to design mathematical equation. So causal relationship, again in very simple term, can be explained as situation in which value of one variable affects the value of other variable. In regression model, we typically assume causal relationship, but not always it actually exists. So you can pick two completely random variables, assume some causal relationship, and get some regression output. However, it will not mean that there is indeed a causal relationship between those variables. That's why you have to be extremely careful when selecting variables for regression model and interpreting those variables. I mean interpreting the output of regression model. Finally, there is a difference between correlation and regression. So when you perform correlation analysis, you just want to analyze the degree of linear association between two variables. It can be positive, it can be negative, and those variables are treated symmetrically. You do not assume that one variable determines the value of the other variable or vice versa. So in such a situation, no predictive analysis is possible. In regression model, there is always some hierarchy. So, okay, hierarchy may be not the proper word, but I wanted to say that you do not treat those variables symmetrically. You assume that one variable is affected by the values of other variables. So there is a causal relationship. One variable is dependent and other variables are independent. Okay, so do not be that afraid. We are gonna discuss all those issues during this course. In next video, we are gonna analyze the types of variables, types of data, and how you collect data for regression model. So thank you for your attention and see you in the next video.